heard of sine, cosine, and tangent? You've heard of that? Okay, if you've heard of it, then it's probably going to be a review, but this is not a bad thing to review. So we're going to talk about sine, cosine, and tangent. Okay. So the first thing that we have to know is that sine, cosine, and tangent, these are relationships in a triangle, but we have to have a right triangle for the relationships that we're going to talk about. So we have to have a right triangle. Oops. Must have a right triangle. So how many of you guys remember what a right triangle is? What does that mean?
One with a 90-degree corner.
Perfect. It has a 90-degree corner. So a lot of the time you'll see this. If you see this, you can know that means that it has a 90-degree angle, and that is a right triangle. Okay. Let's also remember, if I label my triangle, if I have this is A, this is B, this is C, what do these angles add up to? What is the measure of angle A plus the measure of angle B plus the measure of angle C? What do these angles add up to? You remember? Perfect. Good. 180 degrees. We are only going to worry about degrees. You might have heard of radians before today, and while we're talking about this, we're just going to worry about degrees. Okay. Okay, so these relationships that we're talking about, they must have this 90-degree angle somewhere in the triangle for this to work. Okay. All right, so I'm going to draw another triangle. Let's draw a right triangle. I'm going to put a right triangle in there, so that's a 90-degree angle. I'm going to call this one A, this one B, and this one C. And I'm going to look at this angle. Okay, I don't know what it is. I don't know what the angle is, but I'm going to call this measure, this is going to be angle A. Okay, so across from angle A, I have side A. So I'm going to use lowercase letters. Across from angle C, I have side C. And across from angle B, I have side B. Okay, so now we're going to start getting into our relationships. So if I'm looking at angle A, angle A, if I'm looking for the sine of angle A, that's going to be the opposite side over this other side called the hypotenuse. So we also have to know what this word means. What does that mean, the hypotenuse?
Is the longest angle or side C.
Good, it is the longest side. So this would be our hypotenuse. The longest side is always going to be across from the 90-degree angle because the 90-degree angle is always going to be the longest side, or the largest angle. Okay, so our hypotenuse is always the side across from the 90. So if you can find the 90, you can find the longest side. Okay, good. So hypotenuse, longest side. Longest side. Pretty sure that's spelled wrong. That's okay. All right, so we have sine of A. So sine, and we abbreviate, we say SIN, but we can still pronounce it. Sine of A is opposite over the hypotenuse. So here, the opposite of A would be side A. And the hypotenuse would be C. So let me run and grab a calculator and show you. So if I have my calculator, there is our sine. So we've got sine, cosine, tangent. So these always have to go with, right now what we're doing, we need these to go with the angle. So sine of the angle equals the proportion of the sides. Okay, so don't get those confused. All right, so that's sine. The next one we need to talk about is cosine. Cosine of angle A. We could also find the sine of B and the sine or the cosine of B. We're just going to stick with, make it simple, we're just going to look at angle A right now. Okay. So cosine of A is called the adjacent. It's proportional. The cosine of angle A is proportional to the adjacent side over the hypotenuse. So here's angle A. This is the opposite side. The adjacent side is the shorter side that makes up angle A. So I always look at angle A, and then that's the hypotenuse. This must be the adjacent. So this is adjacent. This is the opposite of A. So we can write this another way. We can say cosine, that's what matches our calculator. We still say cosine, but it's just abbreviated. So the cosine of A is the adjacent side. I abbreviate ADJ, adjacent side over the hypotenuse. And our adjacent side is B, and our hypotenuse is C. Okay, questions so far? We're doing okay? All right. So we've done sine, we've done cosine. The last one is the tangent. I'll put it over in this space over here. So the last one is tangent. So tangent of A, tangent of angle A. So here is our angle. This one is the opposite side over the adjacent side. So here we're looking at angle A. So tangent of angle A is the opposite over adjacent. And that gives us A. The opposite side of angle A is A. The adjacent side of angle A is B. So A over B. Okay. So I'm also going to tell you, this is how I remember which ones go with which. I use so, ka, toa. Good. Have you heard of that before? Okay. So this tells me sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this is how I remember. So sine is opposite over hypotenuse. Cosine of the angle is the adjacent side over the hypotenuse. And the tangent of that angle is adjacent side over the opposite side over the adjacent. That's how I remember. Okay, so I would write this on my paper probably. Okay, questions on that? So that's all we have to know so far today, okay? All right, let me hand out our assignment. I also realized the assignment that was in the file, I don't want to do the second page, but it's taken. So go ahead and, when you get this, I want you to rip off the back page and hand it back. Unless you want to do the second page. We'll do the second page another time. This is your second page. Can I have your second page?
Right.
Oh, sorry, I forgot. Okay. All right, here we go. Thank you for doing that. Sorry, I didn't realize that was on the back. Okay, so let's try to do number 1 together. So it says mark angle A. So that's just what we did. So I'm going to mark angle A with this little angle symbol. That tells me that there's an angle there that I'm looking at. The other thing that I'm going to do is I'm going to write this. This helps me. So you write what helps you, but I think this would be helpful. I'm going to write so ka toa. Oops. Toa. And this means that the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is equal to the adjacent side over the hypotenuse. And the tangent of the angle is the opposite over the adjacent. So that helps me to know how to do these. Okay. So here, I need to label the opposite side of A. It says opposite, adjacent, and hypotenuse. Which side is opposite of the angle A?
5.
Good. So it's across from it. This one's opposite. So I'm just going to label that opposite. Label the adjacent side. Which one's adjacent to A?
12.
Good. Adjacent. And which one is the hypotenuse?
13.
Good. Hypotenuse. Good. So I also can look, so the hypotenuse is across from the longest, the 90. The hypotenuse is always across from the 90, but also 13 is the longest side. So the longest side is always the hypotenuse. Okay, so we've got number 2 done. We've got number 1, we've got number 2. Circle the sides that we use for sine. So we need the opposite side and the hypotenuse. So we need 5 and 13. Just decide which side goes on top. So that's opposite over hypotenuse. So the opposite goes on top, 5. And the bottom one is the hypotenuse. So 5 over 13. So the sine of this angle is the opposite over the hypotenuse. Okay, questions on that? We're doing okay? Okay. So I'm going to let you guys do 2 and 3. I think you guys can figure those ones out. Let's try 4 together. So 4 says, all of the ones after 3 say, now we solve for x. So here is x. So we need to set this up and then solve for x. So it says mark A. So we have A, measure of angle A. We need the opposite and the hypotenuse. So this one's the opposite of A. This one is the hypotenuse. So 13 is our hypotenuse. It's the longest side. Okay. So now we need to decide what are we going to use? Are we going to use is this relationship? We have the opposite side and we have the hypotenuse. which trig function, so our trig functions are sine, cosine, and tangent, which trig function goes with the opposite side and the hypotenuse side? Good, the sine. So it says sine of the angle is opposite over hypotenuse. So we're going to say the sine of our angle is 34 degrees, is equal to the opposite, which is x, over our hypotenuse, which is 13. So now we need to do some algebra. So now that we have it set up, we need to solve for x. We have x divided by 13. How will we get x by itself? How do we get rid of that 13? We're going to do the opposite of opposite of divide. We're going to multiply by 13. Good. So multiply by 13 on both sides. So 13 divided by 13 is just 1. So we have 1x is 13 times the sine of 34 degrees. So then we can just plug this part in our calculator. So 13 times the sine of our angle, 34, parenthesis. So our answer is, let's see, does it say? It doesn't say how many. So let's just round to one decimal place. So I have 7.26. This number is bigger than 5, so I'm going to round up. So this will be 7.3. So we just found on our triangle the opposite side of this angle, x is 7.3. Okay, questions on that? All right, there's one more to do here, number 5. Notice that the angle is up here now, so watch out for that. We're not doing this page. Okay, let's do a few of these ones. So let's just start up at the top with, it says find the tangent of z. So we're going to mark our angle, we're marking z, and then we need to label the sides. So which side would be the opposite of z? Good, this one's opposite. Which one is the hypotenuse, the longest side? Good, very good. Which one is adjacent? Good. So in my experience, I have found the adjacent side the hardest to find. So maybe do that one last, because I feel like the last one's easier because there's only one left. So, okay, so now we need tangent. What is the relationship between the angle and the sides for tangent? Tangent of the angle gives us what? Good, opposite over adjacent, perfect. So the tangent of z is equal to, we need the opposite over the adjacent. So opposite is 21. The adjacent is 28. So this would be, we're just looking for the ratio. So that's a ratio. We have a fraction, but we need to simplify our fraction, okay? So we need to, is there something we can divide 21 by and also 28 by? Good, 7. So I'm going to divide both the top and the bottom by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. And now this is simplified. So our trigonometric ratio for tangent of z is 3/4. Okay, I want to show you really quick on this calculator. If I do 21 and then I do this button, so this button right here, I just did the, like, I don't know what you call this, like a little tiny bracket divided by 28. So this is like fraction, 21 over 28. It'll simplify it for you. So that's kind of cool. You can do that. That's fine with me. Was there someone in the hall?
Yeah.
Okay. All right. Do you guys want to do one more on the back, or are you guys ready? What do you want to do? Do you want to do one more? What do you guys think? We can do one more. We haven't done a cosine one. Let's do cosine. Let's do this one down here, 5. So it says cosine of A, so we need to find our angle. This is our angle. And then we need to label our sides. So what side would be opposite of A? Good. Opposite. Which one is the hypotenuse, the longest? Good. Hypotenuse. And then the adjacent is the last one. Adjacent is the side next to our angle, but not the hypotenuse. So this is adjacent. And then we need cosine. Cosine. So SOHCAHTOA. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So we're going to look at the cosine of angle A is adjacent. So adjacent is 30 over our hypotenuse, which is 34. So then we need to think, is there a number that we can divide 30 by and also divide by 34? So these are both even, so we could divide out at least a 2. So let's try that. 30 divided by 2 is 15. 34 divided by 2 is it? Thank you, 17. And now, is there anything we can divide the top and the bottom by? So this one is simplified. So our ratio, cosine of A, is proportional to side 15 and 17. 15 over 17. Okay. And again, you can also simplify using your calculator. You can do 30. And then this button here. This one. 34. And then that simplifies it for you. So that's kind of nice. All right, we have a good amount of time. I think this won't take the whole time. So once you are done, please look and see if there's anything in this class or other classes that you can work on.